Logic! Alright, you're going to have three main types of problems with logic. The first of which is and versus or. Now, if a statement uses the word and, what it means is that for that statement to be true, both parts must be true. On the other hand, if we use the word or, only one part must be true. Alright, let's do some examples here. True or false. Let's look at this first one. Dogs bark and cats meow. Since we have the word and here, it means that both parts have to be true for the statement to be true. So looking at dogs bark, well, we know that dogs do bark, so that part is true. And cats meow. Cats do in fact meow, so we have true for dogs bark, true for cats meow. Both parts are true, so we know the whole statement is true. Let's look at this next one. 2 plus 2 equals 4 and 1 is less than 0. Again, we have an and, so both pieces must be true. 2 plus 2 equals 4, well, that we know is true. First part is true. Let's look at the second part. 1 is less than 0. Well, 1 is actually more than 0, so we know that this part is false. Since it's an and, both pieces have to be true. But we know that 1 is actually not less than 0, so this statement would be false. Alright, let's look at this next one. Fish swim or pigs fly. Alright, now we've got an or. An or means that either part can be true to make the whole thing true. So let's look at this first part. Fish swim. Well, we know that fish do swim, so since it's an or, we already know the whole thing's true because only one part has to be true. So even though pigs do not fly, pigs fly is false, the whole statement is true because it's an or statement, which means only one part has to be true to make the whole thing true. Let's look at the last one. 1 plus 1 equals 17 or 2 is greater than 3. Well, 1 plus 1 does not equal 17. 2 is not greater than 3. So since neither part is true, the entire statement is false. Alright, next we have inductive reasoning. Inductive reasoning means that you're going to use patterns or an example, something that you can see, observe, and you're going to make a prediction or a conjecture based on those patterns or examples. You might come across this word conjecture. Conjecture just means make a prediction or make a guess at what can you say based on those patterns or examples. So let's say we had a pattern down here. Let's say we had a red square, blue triangle, red square, blue triangle, red square, and you needed to make a conjecture about the next shape in the sequence. Well, you might say, obviously, we have red square, blue triangle, red square, blue triangle, red square. The next shape is going to have to be blue triangle, and you would be correct. And that is an example of using inductive reasoning. Alright, go ahead and make a conjecture based on this given information. Let's say that we had BA, this ray here, was perpendicular to this ray BC. So we need to use this information to make a guess, make a claim that we can predict would be true. So since I know that perpendicular means 90 degrees, I know this is a 90-degree angle right here. So my conjecture might be that the measure of angle ABC is equal to 90. Deductive reasoning is using statements that are accepted as true to deduce or to make true conclusions. So here we have deductive, not inductive, deductive reasoning, and we're basically going to be given a certain pieces of information, certain statements, and based on that, what kind of conclusion can we make? So let's take an example here. Let's say that we're given that all pigs fly. Now, it doesn't matter if this statement is true or false in reality. It's given to us, so we accept it as true. And let's also say that Charlie is a pig. Okay, so looking at our two statements, we have all pigs fly. Charlie is a pig. What conclusion might we be able to make? Well, since Charlie is a pig and all pigs fly, we can say that Charlie can fly. Now that would be a true conclusion based on our given information. That is deductive reasoning. Okay, when using deductive reasoning, you need to be very careful because sometimes they like to get a little tricky on wording. So let's do this example. Let's say we want you to say whether or not the conclusion made is true or false. And here are statements. All learners like to study. Mr. Zonker likes to study. And here's the conclusion. Mr. Zonker is a learner. So it might seem that that would make sense based on the given information, but let's look closely. They're telling us that all learners like to study and that Mr. Zonker likes to study. It is possible that Mr. Zonker is not a learner, but he still likes to study because we don't know. Maybe facilitators like to study as well. We're not given that piece of information. So based on these given statements, we can't say that this conclusion is true. We'd have to say it was false. You need to be very careful when making a connection between statements. One has to directly lead to the other.